Hey, welcome back to your favorite fundamentals of college math class. We're going to take a look today at our exponential equation. So we've looked at when we've had a constant rate of change, like with lines, right? That's an increasing, and it's got a constant rate of change. And now we're going to look at stuff that grows exponentially. So it's got some curvature to it. So this is an exponential growth curve. This would be like an exponential decay curve. Okay, let's start and compare a constant rate of change compared to an exponential on this one. So company A has 100 stores and expands by opening 50 new stores a year. So if we were filling this out, year zero's got 100 and it grows by 50. So the next year I got 150. And then it grows by 50 again the next year. So now we got 200, 150 plus 50. And then 200 plus 50, 250, right? So that would be company A. It grows by 50 stores per 1 year, right? So it's a constant rate of change on that. Now, company B, on the other hand, increases by 50% of the total from the prior year. So if it starts out with 100, previous year, after the first year, then it still have the 100 and then 50% of that 100, which is 100 plus 50. So you still end up with 150 the first year. But then at the end of year 2, you're starting out with 150, but you're adding in 50% more. So 50% of the 150. Well, 50% of 150 is 75. So I got 150 plus 75, we got 225 stores. And so then end of year 3, we'd have 225 and 50% of that 225. And that ends up being 225 plus that ends up being 337 and a half. So about 338 stores. Okay. So I want to just show you in Desmos. If you want to pull up desmos.com, and we're going to go ahead and we're going to graph these companies with that graphing calculator. So desmos.com, graphing calculator, open graphing calculator. And if you look up here, click on that plus right there on the upper left, and you can open up a table. And let's do company A. Company A in year 0 has 100 stores. In year 1, it had 150. In year 2, it had 200, and so on. And now I'm going to click down here. Let's do company B now. I'm also going to click plus and a table again. And then I'll put in this one. So 0, it had 100, and then it went up by 50% each year. So 2 was 225. Year 3 was 337.5. Year 4 was 506.25 if you were to do that one, 50% more each time. Now, I know you can't see these points because our window is bad. So if you go up here to your wrench in the upper right, see the little wrench right there, graph settings. I'm going to click on that. And I'm going to put this, let's go from like -1 to, I don't know, let's go up to, we'll go to 10 there. Label it by 1. But I got to change my x-axis here. So that should be, or you know what, let me go -1 to 20. And then let me do my y-axis negative 100. And notice I go up to like 759. So let me do like 900. It should be a decent one. And step it every 100. Label it every 100 on the y-axis. You can kind of see you see how the green one there, maybe I'll zoom in a little better. But the green one there, I wish I could draw on this, but I can't, unfortunately, unless I rip that image. So the green one, though, is linear. Can you see how that's a straight line? And then the blue one has got that curvature to it, right? It's growing exponentially. So that's just a showing of that. Well, here's those two graphs, and here was company A, that linear growth, and then we're just hoping that you'd see, oh, they changed. Whoops, I didn't call those lines too well, but there's your exponential growth on that second company. But let's go ahead and summarize all this. So an exponential equation is going to be of this form. Y equals A times B to the X. A is the initial value. Why is A the initial value? Because if I'm in like year 0, if I let X be 0, anything to the 0 is 1. So you're just left with A. That's why A is the initial value. Think of it in terms of like time being 0 or whatever. Okay. So A is your initial value or the starting value when X is 0. And B is your growth factor. So how fast does it grow? If the B value is bigger than 1, you're going to have a graph like we just showed. So it'll grow exponentially. If the B value in there is less than 1, it's going to be an exponential decay type of a situation. It decays exponentially. Okay. And then here's a couple where if you have like a rate, if it's a growth, it'll be the top one. If it's a decay, it'll be the bottom one. So instead of a B in the parentheses, I have 1 plus R, which is your B value. Okay, we'll work some of these problems here. So let's complete this table below with this information. All right, can you see how that value is bigger than 1? All right, so this will be an exponential growth. All right, because that y equals A times B to the X. If that B is bigger than 1, it's going to be a growth. Now, I'm going to write the growth with 1 plus R to the X. So I can identify how much or how fast it's growing, its rate as a percent. Okay. As well as I'm going to identify my initial value. So my initial value is the A in front. You see the 430? So that's my initial value. In other words, if X is 0, it'll spit out 430, because anything to the 0 power is 1. 430, 1.15 to the 0. Anything to the 0 is 1. That's why that number in front is our initial value, right? So 430 is our initial value. This is a growth because of its 1.15. It's not a value less than 1. It's a value bigger than 1. Now, what's the rate? Well, I look at that 1.15, and I'm going to go ahead and I'm going to set it equal to 1 plus R. So let me write this. 430, 1.15 to the X, A 1 plus R to the X. So my 1 plus R, I'm going to set that equal to 1.15, and I'm going to solve for R. So my R equals 0.15. But I want that as a percent. So 15 100ths, of course, is 15%, right? 15%. So that's how fast that one's growing, at a clip of 15%. All right, let's look at the next one. Y equals 23 times 0.8 to the X. So I'm looking at that and I'm like, okay, it's less than 1. Right, this is my general form, A times B to the X. If B is less than 1, we know it's an exponential decay. So I'm going to go ahead and write that's a decay, exponential decay. And I'm going to use it where I can identify the rate. So Y equals A 1 minus r to the x. So my initial value will be that 23. If I let x be 0, it'll spit out 23 for me. But what's it decreasing by? What's my rate of decay? What's my rate of decay? Because this one was a rate of growth. This one, and the one we're doing now, will be a rate of decay. So I say, well, 0.8 must equal, 0.8, sorry, must equal 1 minus r. So let me subtract 1, negative 0.2 equals negative r, divide by negative 1 on both sides, so I get a positive r equals a positive 0.2. So r equals 0.2. In other words, 0.20, so 20% is my rate of decay on this. All right, this next one I'm looking at, I'm like, hey, they're telling me it's a growth, so I'm going to go ahead and write a times 1 plus r to the x. And I know if it's growth, I know that 1 plus r, that b value, if you will, in there is going to be bigger than 1, right? And they also tell us the initial value, so they give us the a value. Let's put that in right there. And they tell us the rate. They tell us r. R is 5%, so let's put in 0.05. And now we've got our equation, 1.87 times 1 plus 0.05, so 1.05 to the x. And there's our equation. Now the next one says it's a decay function. So I'm going to use a 1 minus r, because it's an exponential decay. The initial value they tell me is 52. The rate it decreases by is 10%. So this one will be 52 times 0.90 to the x. So here it's giving us an exponential growth equation where T is the total number of Android smartphone contracts in thousands. That's your T 86. So that 86 there would be, well, we'll talk about each of these parts. And then it punches it in for us, right? Q is in quarters. Interpret all parts of the equation. Well, I'm thinking to myself, A, and then 1 plus R. In other words, that's my B to the X, all right? This is exponential growth because that 1.64 is greater than 1. So what's the 86? Let's start out with that. Number 1, 86 is the initial value. When is it? The initial value on January 1st. So the region had, if it's 86, remember this is in thousands, there's 86,000 Android phones. Bless you. And that held by a certain Verizon region, right? So number 2, what else? Well, let's look at the growth rate, that 1.64. Yeah, compare that to 1 plus r. So if 1 plus r equals 1.64 and I solve for r is 0.64. So every quarter, or 64%. So every quarter, smartphone contracts are growing by 64%. Huge growth, right here. Thirdly, they give us the total, 231.33056. Notice this is after 2, right? After the second quarter. So after quarter 2, Remember, this is in thousands. 231,305.6, so about 231,306 contracts is what this is telling us. So on this example, I want you to tell me, is it an exponential growth or decay, or is it just linear? Is it a fixed rate of change? So number one, cost of living allowance for state employees increases by 3.1% per year. What would that be? You'd say exponential. Specifically exponential growth, right? But that's exponential. Number two, the value of an investment is increasing by $300 per year. Exponential or linear? Linear. That's a fixed amount every year. $300. That's a linear, constant rate of change. Tuition costs have increased by 2.8% each year for the last 3 years. Again, a percent, so you're going to say what? Exponential. Those dirty buggers raising the tuition all the time. So you've got a couple equations here. I want you to compare them. So which one is grows faster? So you're comparing the rate, right? And notice both of these have values bigger than 1. So we know they're both exponential growth. So this first one is growing at what rate? %5 rate, right? B is growing at, subtract 1 on both sides, 7.5%, right? This is a 5%. This one's growing at 7.5%. So who grows faster? So number one, faster, we would say company B, or account B. I guess these are savings accounts. But then the question, well, what about after 3 years? Which one would have the higher value? Because notice in account A, I'm starting with more money than I'm starting in B, right? In account A, I have $1,000 I'm starting with. Even though it's only growing at 5%, account B, I'm starting with a lesser $900, but it is growing faster. So then the question is, who's got more money after 3 years? Well, let's do the math. Plug a 3 in, and we're going to punch that in, and then we'll compare it to B. There. So let me pull up my Desmos, desmos.com, scientific calculator, and let's punch those 2 in. Math tools, let me go to the scientific. So I've got 1,000, 1.05, shift 6 to make it to the power, or you can use this A to the B button right there. So it looks like that one ends up being 1157.625. The other one started with 900, and it was growing at a 7.5% clip for 3 years. So it looks like it only has 1118.07 cents. So let's go back, write those down. So who has more? Therefore, A has a higher balance savings, right, after 3 years. In the year 2008, that India's population was that. So make a note here. They're telling you that's the initial population in that year, right? That's like time 0. and it's growing at a rate of 1.34% per year. Write an exponential equation for India's population. Use it to predict the population in 2020. So note 2008, or year 0, population is 1.14 billion. Okay. So let's see if we can't set up. We know this is growing 1.34% per year. So let me write an exponential growth model. So I write that y equals a, 1 plus r to the x. And the initial amount, so year 0, and we'll make it population P, ends up being the initial amount. So this is in billions. 1 plus my rate. How fast does it grow? 1.34%. Well, 1.34%, make sure you put that as a decimal, is 0.0134. 0.0134. And to the x power, this will be time t in years. Time t in years. So here's our model in billions. This is in billions. That would be our population. Now they want us to predict it in the year 2020, right? In the year 2020. Well, if 2008 is year 0, 2020 is how many years later? Yeah, 12 years later, exactly. So let's go ahead and plug that in and find out this population for the year 2020. So we've got our model we're going to use. And now we just punch this into our calculator. And we'll get 1.7136 billions. All right, that's in billions. So in other words, that many people. 1,337,441,360. All right, here we've got a little chemistry here. Bismuth 210 is an isotope. It decays, radioactively decays. So this is an exponential decay situation. So I'm going to go ahead and write my exponential decay, 1 minus r to the x. Okay, so it decays at about 13% each day. So there's my r, 0.13. Meaning 13% of the remaining transforms into another atom each day, right? If you begin with, there's our initial amount. So there's our A, 100 milligrams. How much remains after 1 week? We're beginning with 100 milligrams. I'm decaying at 13% time t. This is in days. So there's our t, where time is in days, right? That's how much we have left. So we're going to do it after 1 week. So that would be 7 days, right? You punch that in. Of course, if you're doing them separately, make sure you always do the exponential first. If you're not going to use the parentheses and everything in Decimal Scientifics, you do 0.87 to the 7th, and then you multiply by the 100 in front. But you'll end up with 37.73 milligrams after. So that thing exponentially decays. That's how much of that isotope you have left after a week. Let's move on to our last one here. An investment is initially worth 10,000. So this is what we're starting out with. That's our A. We're starting out with 10,000 bucks. Write a formula for each of the situations. So part A, I know my initial is 10,000 and I'm increasing by 5%. So let me go ahead and write exponential growth here. Increasing by 5% every year. So I have y equaling 10,000, 5%, that would be 0.05, so 1 plus 0.05. I'm going to do time in years here. So we got y equals 10,000. Oops, I had to add in another 0 there. 1.05 to the t. There's our formula. We could figure out how much we'd have after time in years. Part B. We still have starting with 10,000 bucks, but it's 5% every 3 years. 5% every 3 years. So that's a little different if your time is in 10,000. It goes up. If you're going to leave this as 5%, then you got to cut this in a third, right? Every 3 years that happens. So if you think about that, after 3 years, if I plug 3 in for t, I would have 3 over 3, which is 1, and it goes up by 5% one time, right? After 3 years. After the 6th year, now it goes up another 5%, so on. That's why I cut that in third. Now, on the other hand, if you have one, you start out with 10,000 bucks, but it's 5% every 6 months, so twice a year. So you got 10,000 goes up 5%, but twice a year. Then I want to double that time because t is time in years, right? So, for example, if I do it for a half year, t is a half. 2 times a half is 1, so it'd go up 5% in 6 months at the half year mark, right? Well, thanks so much for watching, and we'll see you guys next time.